Now let's look at another example where here we are given the set of Venn diagrams, a similar design as before, but now we got our regions defined in a bit more detail. The labels have changed a little bit. We have sets that we can discuss, where our goal is going to be to describe the union of A and B, intersection of it, complement of A union B, excuse me, the intersection of A complement and B complement, and the union of A, B, and C. So, first thing we're going to want to do here is properly define the sets we're looking at. So notice that A consists of the regions 1, 2, 4, and 5, and as a set would be 3, 5, 6, 7, 11, and 12. Meanwhile, B would end up being the regions 2, 3, 4, or 2, 3, 5, and 6. Excuse me, I can't read Roman numerals sometimes. Means that there we get set 1, 2, 5, 7, 9, 10, 12. Next, we got C, which is the regions 4, 5, 6, and 7. That ends up being 5, 6, 7, 8, and 9. That's usually the first thing I'd recommend with this kind of problem. Start out by writing out what each of your sets is in terms of roster notation. It's usually easier to talk about these set operations if you know exactly what you're looking at. So, now that we have our pieces, we can start putting them together. A union B, we're looking at compiling every possibility we have between these two. So we've got 1, 2, 3, 5, 6, 7, 9, 10, 11, and 12. A whole bunch of things. 1, 2, 3, 5, 6, 7, 9, 10, 11, 12. If we take their complements, we'll get A union B complement of these sets. We'll see that everything we've got in here consists of everything but 8. Oddly enough, there isn't actually a 4 to be in this complement. There's no 4 on the Venn diagram. So you just get 8. Meanwhile, if we take their complement separately, we would get A complement equal to what we've got in there other than up there. So we get 1, 2. Surprisingly, we will skip 4. And then get 8, 9, 10. Now for B complement, again, look up here. So we get 3, 4, 6, 8, and 11. So, take the intersection of these two sets. We will end up the only thing that's shared between them, 8. Yet again, we have seen that if we take the intersection of complements, we get the same thing as the complement of a union. Now let's do one more case for good measure. Here, we can see that if we take A union B union C, since there is nothing outside of those 3 circles, there's nothing in the region 8, this is going to end up being the entire region U, which here is 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, Ran a little low on space, but that's the idea.